Okay, let's continue this video. So now we want to talk about number 3, matching the rational function with the graph. Okay, so number 3e, then you see that the function is fx equal to 1 over x plus 1. So based on this, we found already x cannot be negative 1 from the previous video, right? If you don't understand how I found x cannot be negative 1, please practice after watching my previous one. Okay, so now, before we are drawing this graph, let's think about the parent function, which is y equal to 1 over x graph. So explore the behaving graph of this function first, then we can talk about fx function again. So I will explain that using the GeoGebra. So this is the y equal to 1 over x graph. So I'm gonna zoom out more so you can see a little better. So I'm gonna zoom out y-axis, then what happened here? As you see, it is kind of touching the y-axis. But do you think it is actually touching this y-axis? So more visualizing, I'm gonna zoom in x-axis. So if I zoom in more and more, then what do you see? Do you see the gap between this line and then y-axis? Before it looks like exact touching on y-axis, but now I zoom in x-axis more, you see the gap here. So let's do a little bit more. So zoom out more y-axis, then you see again it touching y-axis. But if I zoom in x-axis more, then do you see gap again, right? Then what can you conclude based on this fact? So graph looks like this and this, but this line never touch this y equal to y-axis, which is x equal 0 line here. And this line, we have a special name for that. This is our vertical asymptote. Okay, so I'm gonna call from here VA as a vertical asymptote here. Okay, then now in this case, x cannot be 0, and then this x equals 0 line or y-axis, it is the vertical asymptote, which means that x equal to 1, that is our vertical asymptote for this fx function. Okay, so let's compare what that means using the GeoGebra again. So I'm gonna just make a standard scale one more time so we can connect this better way. So this is the 1 over x graph. Now I'm gonna draw y equal to 1 over x plus 1 graph here. Then this is the y equal to 1 over x plus 1 graph. So what do you see? It's a little bit confused, right? So I'm gonna turn off y equal to 1 over x, and then we know that from the lecture note here, x equal negative 1. Sorry, negative 1 is our vertical asymptote. So I'm gonna draw another line, x equal negative 1, then it may be a little bit more visible. So after drawing x equal negative 1 line, and then I zoom out y-axis, as you see, this red graph kind of touching y-axis, but we know that this is not actually touching. It close to y-axis more and more. Now y-axis x equal to negative 1 line more and more, right? Simply we zoom in x-axis, then we can see better, right? Like that. Make sense? Yeah, therefore based on this graph, now we can say fx equal to 1 over x plus 1, then this one somehow moving from here, it was the original, moving 1 unit to the left for everything. So before, it was our vertical asymptote. Now, new vertical asymptote is 1 unit to the left here, and then the graph becomes like this, right? Then what about if I give you gx equal to 1 over x minus 3? Can you conjecture this function's graph? So this is like a function transformation. So we know that the original parent function graph was this. Now this case, in moving right to the unit 3 units basically. So before there was the vertical asymptote. Now in moving 3 unity right, so 1, 2, 3 here, then it's going to be our new vertical asymptote. So our new graph looks like this. Okay?